Here we're just going to look at one very specific question that exemplifies a mistake that a lot of you are making on these geometric sequence questions. So in this question, it's question 3b from exercise 7c, and we are asked to try to work out how many email users there's going to be in 2019 if there's 1.7 billion in 2008 and that number increases by 6.2% every year. So the part we have got is understanding it's a geometric sequence, and that means we're going to be multiplying by, in this case, this multiplier every year, and that's going to be our common ratio, our R value. And we've got this information here. People are pretty happy seeing that that is the U1 value, that's the first term of the sequence. But the problem we've got is, how do we go from here using this to get to specifically this year here? A lot of people making mistakes on how many times you need to multiply by this to get from here to here. And I think the confusion is trying to make an nth term and then trying to directly link the n to the specific number here. But the n might not be 19 or 9. You have to look at the context of the question and very carefully work that out in each case. So I'll show you exactly what I mean in this question. So we know that R is 1.062, and we know that the first term in this sequence is going to be 1.7. But actually, let's just come away from the nth term for a second here and think about it this way. So here's the years in the question: 2008, 2009, 2010, 11, 12, and we're going to go up to 2019. I want you to think about how many times you have to actually do this calculation to get to 2019. And you can see that I'm just writing these all out, which you won't have to do each time, but in this case I think it helps to visualize what's actually going on. You need to multiply by this once to get to 2009, twice to get to 2010, 3 times to get to 2011, 4 times to get to 2012, and if you carry on, you can see you're always a certain number ahead of the year. So 4 lots of this gives you 2012. So if you're trying to get to 19, then you want to get 2 ahead of that in a way, and that means you're going to be doing this calculation, the power of 11. 11 of these is going to get you up to 2019. Another way to see the pattern might be that once got you to 2009, and it's pretty clear that to get from 2009 to 2019 is going to require 10 multiplications plus the one that you did at the start, so 11 of these in total. Now that's the answer to the question. You don't need to do anything with the nth term at all in this question. I'd prefer if you try and work it out in this kind of, I guess, more basic way, not using the formula at all, just thinking how many times do I need to multiply by this to take that journey from our starting point to the time that we actually need. However, the nth term is a useful thing to be able to do, and it's important to see how that can link into this question as well. So the nth term is written exactly as you'd think. We are going to do 1.7 times 1.062, and we know the nth term is n to the minus 1. The n minus 1 bit, I think, is what's causing the confusion here, because if you think, well, I've got to do 11 steps, therefore I'm going to make the power 11 minus 1 equals 10, that would be wrong. The 2009 is actually the 12th term in the sequence, hence why when you do 12 minus 1 it does give you the power of 11. And the way you will see that is if you properly write the sequence out with the terms, maybe with the years as well, but also with the correct n values, you'll see how that works. So the first term is when n is 1, n is 2, n is 3, n is 4, n is 5, and so on. And again, you'll see if you want to get to 2019, well, you can see there's kind of a gap of, looks like there's a gap of 7 here. So if you want to get to 2019, that's going to be when n is 12. You stick 12 in there, 12 minus 1, gives you the power of 11. The key thing is that n is 1 in the year 2008. And that works quite nicely because if n is 1 here, you do 1 minus 1, so the power becomes 0. In other words, this whole thing disappears and you just get that first term. That's why it's n minus 1. But you have to include that as the first term. Therefore, that's the second term, that's the third term, that's the fourth term, that's the fifth term. 2019 is the 12th term, therefore power of 11. Okay, hopefully that makes that question a bit more clear. Have a look at it again if you didn't get that one right and see if you can see how this works.